everyone, welcome to this video where we will look more deeply at the behavior of the sine graph. Previously, we defined the sine function so that y equals h of t equals the sine of t. So if we were tracking a point along the circumference of the unit circle, the y coordinate of that point would be a function of the angle t. So again, let's look at the behavior of the sine graph in more detail. So here we have the unit circle in blue and the sine graph in green, and we want to give the largest intervals possible and the corresponding quadrants where the graph of y equals h of t equals the sine of t is positive, negative, increasing, decreasing, concave up, and concave down. So to begin, let's identify where the quadrants in the unit circle correspond to the sine graph. So we know that if we start on the positive x-axis, that would be an angle of 0, and the first quadrant ends at pi over 2. So this black traced area is quadrant 1. And we know that quadrant 2 begins at pi over 2 and ends at pi. So this purple traced area represents quadrant 2. And then moving along from pi to 3 pi over 2 represents quadrant 3. So this orange traced area is quadrant 3. And then lastly, quadrant 4 is between the angles of 3 pi over 2 and 2 pi. So this kind of aqua color here represents quadrant 4. So take a minute to decide for yourself where the sine of t satisfies each of these conditions, both by giving the interval or intervals and the quadrant or quadrants where these properties are true. Okay, so for the sine function to be positive means that the sine function is above the t-axis, and we see that that is true from 0 to pi, and we know that from 0 to pi is equivalent to quadrant 1 and quadrant 2. For the sine function to be negative would mean that the graph is below the t-axis. So that is true for pi until 2 pi. And we know that all the angles between pi and 2 pi are located in the third quadrants and fourth quadrants. All right, next, where's the sine function increasing? So where would the sine function have a positive slope? And we see that that is true from 0 to pi over 2, as well as from 3 pi over 2 until 2 pi. And so that's quadrant 1 and quadrant 4. The sine function is decreasing from pi over 2 until 3 pi over 2, and that corresponds to quadrant 2 and quadrant 3, right? In quadrant 2, the y values are decreasing, and in quadrant 3, the y values or y coordinates are also decreasing. All right, so next we want to look at where the sine function is concave up, and so we see that the sine function is concave up from pi until 2 pi. So that's quadrant 3 and quadrant 4. And the sine function is concave down from 0 to pi, which is quadrant 1 and quadrant 2. So we're going to look at a couple more things here. So we still have the sine graph. Now we want to identify where is y equals the sine of t increasing and concave up. So we know that the sine function is increasing from 0 to pi over 2 and from 3 pi over 2 until 2 pi. And we only want to know where the sine of t is increasing and concave up. So we see that's actually true, on the interval 3 pi over 2 to 2 pi. And what does that tell us about how the sine of t is increasing on this interval? Well, we can see that this graph is increasing and it's getting steeper. So we could say that the sine of t is increasing faster on that interval. And then the next question asks us, where is the sine of t increasing and concave down? So that was the other interval we saw. On the interval from 0 to pi over 2, the sine graph was increasing and concave down. And so now we see that the slopes are decreasing. So the sine function, it's still increasing, but it's increasing slower. So the sine of t is increasing slower. It's important to notice there, the sine function is increasing, but the slopes are decreasing. All right, so last one here. Where is the sine of t decreasing and concave up? Well, we know the sine is t is decreasing from pi over 2 to pi and from pi to 3 pi over 2. And I broke that up into two intervals because we see that at the midline at y equals 0, the graph actually changes concavity. So the sine of t is decreasing and concave up on the interval pi to 3 pi over 2. Right? So the slopes are negative, but it looks like the slopes are getting less negative, which is actually telling us that the sine of t is decreasing slower. And lastly, the sine of t is decreasing and concave down on the interval pi over 2 to pi. And that tells us that the sine of t is decreasing faster. All right, so we see that the slopes are negative, but they seem to be getting more negative. The graph seems to be getting steeper as t gets closer to pi. So sine of t is decreasing faster on the interval from pi over 2 to pi.